Hello students, welcome to the first video of this new playlist. So in this video we will be solving the first question from S1, that is Statistics 1 May 2024 paper. So this will be the new playlist where I will be solving the whole Statistics 1 May 2024 paper. So I'll try to explain as much as possible in each of the solution videos for each of the questions. So wherever you find any mistake or any problem, then feel free to write it below the comment box on that, like below that specific video, and I'll definitely look onto it. So let's start with the first question from S1 May 2024 paper, and let's see what's the question number 1. The first question is about. So if I give a brief review of the background of the first question, this is basically the concepts behind this question is from chapter 2 and chapter 3. That is, chapter 2 is basically measures of location and spread of your statistics S1 book, and the chapter number 3, this is basically representation of what? Data. Okay, so in order to be able to solve this question, you should have definitely solved questions from chapter 2 and chapter 3 of your S1 textbook. So let's get started with the first question of May 2024 paper. Okay, so a researcher is investigating the growth of two types of tree, birch and maple. Okay, the height to the nearest centimeter as seedling grows in 1 year is recorded for 35 birch trees. How many? 35 birch trees and 32 maple trees. Okay, the results are summarized in the back-to-back stem leaf diagram. Back-to-back stem leaf diagram below. Okay, what is a back-to-back stem leaf diagram? Definitely you have learned about stem leaf diagrams in chapter 3, that is representation of data. So in a back-to-back stem leaf diagram, there will be a single stem, like here. This is the stem. This is the stem, and on its either side there are two leaves, maple and birch. That's how it works. Okay, and how you can interpret this back-to-back stem leaf diagram? This is basically with the help of the key. The key says 5 to 6 to 3 means what? 65 centimeter for a birch tree, okay, and 63 centimeter for a maple tree. Fine. Okay, next, what they said next, the median height that these maple trees grow in 1 year is 45 centimeter. Okay, the median height. Median is what? Median is basically Q2, right? Q2 is given as 45 centimeter. Okay, fine. We know the median. Fine. So they are asking to find the value of K used in the stem and leaf diagram in part A. In part A, they are asking to find the value of K. Okay, let's see what is K. Okay, K is basically which term? 5, 7, that is 12, 12 and 12, 13, 14, 15, 16. So K is basically the 16th term in the stem leaf diagram. Okay, so before asking for finding the value of K, they said what? The median height. That means we need to make some relationship with the median of the data. Okay, so let's make this relationship. For a data, median, like median, quartiles, these things depends on what? These quantities depends on the total number of data. So here the total number of data is how much? It is 32, right? It is 32. There are 32 maple trees, so n is 32 here. Okay, so n is basically even number, right? 32 is an even number. So for even number, what we know, the median is basically the what? Average of the middle term, and it's just the next term. Okay, so here the middle term is what? The 16th term, since 32 over 2 is what? 32 over 2 is 16, and its next term is what? Its next term is 47. So median would be the average of the what? Of the 16th term and the 17th term. So 16th term is what? How can you interpret the 16th term? Let's see. They said 6 to 3. 6 to 3. This is basically 60 plus 3. That makes it what? 63. So like as that, what we can say for 4 to k. So 4 to k would be what? 40 plus k. Fine. 40 plus k. So we got the 16th term. So let's consider the what? The median. Fine. So for part A, what would be the value for Q2? Q2 would be the 16th term. The average of the 16th term, that is 40 plus k. And the 17th term, what would be the 17th term? 17th term was 47. Yeah, 47 over what? Average. So 2. Fine. So 40 plus 47, that is basically 87 plus k over 2. This is equals to how much? What was the median? They said 45. Okay. Okay. So k plus 87, it is equals to how much? 90. So what would be the value for k? K would be 90 minus 87, that is 3. So we got the value of k. Done. Part A is done. Next, for part B, they are asking find the lower quartile. Okay, lower quartile is what? Q1, and the upper quartile, that is Q3, right? Upper quartile is basically Q3. Okay, upper quartile of the height grown in 1 year for these birch trees. So now they are asking for the birch trees. Okay, so for the birch trees, I said earlier that median quartiles, these quantities represents, depends on what? On the number of data. So here there are total 35 birch trees, isn't it? There are total 35 birch trees. So since there are total 35 birch trees, so which is what? Even? No, it's odd. So 35 is odd. So if the total number of data is odd, then how do we consider the quartiles? Let us consider the lower quartile, Q1. So Q1 is basically what? The data which lies on the 25% of the whole data, right? So 21% is what? Sorry, 25% is what? 1/4. 25 over 100, that is what? 1/4. So 1 over 4 times n. So that would give you how much? 35 over 4. This is basically 8.75. 8.75. So you can write what? 8.75. Should we round up or should we round down? In this case, most of the students get confused. Look, in chapter 2, in quartiles part, it is clearly written, like if the total number of data is what? Odd, then always you will get a decimal value for the while finding the term, okay, number of term. So in that case, as you get the decimal value, you will always round up. It's clearly written. So we will always what? Round what? Up. So that is 9th term. So for 9th term, let's look for the 9th term from the stem leaf diagram. 9th term would be what? 2, 8. Okay, 2, 3, 4, 5, 6, 7, 8, 9. So 9th term is 3:9, that is 39, isn't it? 39. So 39 centimeter is the what? Is the lower quartile. Okay, 39 centimeter is the lower quartile. Done. Next, the upper quartile. Same method, but upper quartile is basically the 75%, that the data that lies on the 75% of the whole data. Okay, so this is 75% is basically 3 over 4 of how much? 35. The total number of data is 35. So what we will get? 3 times 35 over 4. This is 26.25. 26 point what? 25, which should be rounded up. That is 27th term, right? So 27th term is what? Let's look for the 27th term from the stem leaf diagram. 27th term is basically 2, 8, 10, 19, 2, 10, 19, and then what? 28. So 27th term is what? This one is the 27th term, right? Just before the 28th term. Yeah, so this is 57. So we got the upper quartile, that is 57 centimeter. That's it. So lower quartile is 39, upper quartile is what? 57. Done. Next. Okay, next what they said. The researcher defines an outlier as an observation that is greater than Q3 plus 1.5 times Q3 minus Q1, or less than Q1 minus 1.5 times Q3 minus Q1. Okay, so we need to show that, Percy asks to show that there is only one outlier amongst the birch trees. Okay, amongst the birch trees there is only one outlier. We need to show that. Okay, so in order to show that an outlier, what we need to do? At first we need to find out the upper limit for an outlier and the lower limit for an outlier. So consider the upper limit at first. Okay, so upper limit would be what? For part C, at first consider the lower limit. Lower limit would be what? Lower limit is Q1. Q1 was what? What was the Q1? It was 39 minus 1.5 times Q3 minus Q1. Q3 is 57 minus 39. So lower limit is what? 1.5 times 57 minus 39. So that is 39 minus 27, which is 12. Fine. So that is 12 centimeter is the what? Lower limit. Okay, and then consider the upper limit. Okay, so upper limit would be what? Q3 plus Q3 is what? 57. So 57 plus 1.5 times how much? 57 minus 39 is basically what? 22. Sorry, it's 57 minus 39. It's basically 18. Yeah, 18. So what would be the upper limit for the outlier? This is basically 69. Okay, so wait, 1.5 times 18, that is 27. So not 69, it's basically 84. The upper limit is 84 centimeter. Fine. Now outlier would be if the data value is less than 12 or greater than 84. Okay, let's see. Let's look for any data that lies less than 12 and greater than 84. There lies, look, 8:5, right? Which is greater than 84. Okay, so what we can write? So there are no data what? Less than 12, right? But there are what? 85. There is a data that is 85 centimeter. It's what? Greater than 84 centimeter. Hence an outlier. Fine. Hence this is an outlier showed. Done. Okay, next is what? Next is part D. What they have asked in part D. Okay, the grid on page 3 shows a box plot for the heights that the maple trees grow in 1 year. Okay, so part D asked to draw a box plot for the heights that the birch trees grow in 1 year. Okay, we need to draw a box plot. Okay, For drawing a box plot, so basically the concepts of box plot you have learned in chapter 3 in representations of data. So in box plot, what we do actually, we represents the quartiles, right? Quartiles, range, outliers, and what? Yeah, we represent quartiles, range, and outliers. Okay. So we have all the quartiles. We know the all of the quartiles. We know the outliers. We know the range. So just we need to draw the box plot. Okay. So what's the starting value? The starting value is what? Here it is 28, right? The smallest value is 28 without an outlier. This is not an outlier. 28 is the starting value. So the box plot, it's given, the grid is given here. So it starts from 28, right? 28. So 25. So 28 goes for here. So 28. So this is the what? Starting value. Okay. It will start from 28, and then from 28 the Q1. What we got the Q1? Q1 was 39, right? So it will go for 39 next. So this is 39. This is 39. Fine. And then the median. What was the median? Median was. Do we know the median? Okay, no, the median is unknown. So median is basically what? N over 2. That is 35 over 2. Or N was 30. Okay, 35 over 2. 35 over 2 is what? 17.5. That is 18th term. So what's the 18th term here? So 2, 10. So 10, then 19. Right? So 19, 8. 18th term. 18th term is basically 48. Right? Median is basically 48. Okay, we got the median. That is 48. So 48, where does 48 is? 48 is here. So this is 48, the median, and at last, what? The upper quartile. Upper quartile is what? It was 57. Where does 57 goes? 57 is here. So this is basically the what? Upper quartile. Done. Now the upper range. The upper range is what? The upper range is basically, is this 85? No. Upper range would be the maximum data value, the highest data value without an outlier. 85 is an outlier, so upper range would be 76. The upper limit is what? Upper data is what? 76. Okay, it would be 76. Where is 76? Here. This is the upper range, 76. Done. Now just mark out the outlier. Outlier is what? 85. 85 is the outlier. So this is 85. So outlier would be what? Here. This is an outlier. Done. Now we just need to connect the boxes. Okay, just connect the boxes. Done. So this is basically the box plot. Fine. Okay, let's see the next, what they have asked next. That is in part D. So in part E, basically, yeah, part E. Part D done. Just the box plot. Okay, comment on any difference in the distributions of the growth of these birch trees. We need to comment on any difference, like in the distributions of the growth of these birch trees and the growth of these maple trees. Okay, so they said they have given a hint. State the values of any statistics you have used to support your comment. Okay, so we need to consider the difference, whether there is any difference between the distributions of the birch trees and maple trees. So let's see from the box plot. Can you like figure out any differences here? Yeah, definitely there are some differences like notable here. Look, for differences, like when the question asks for differences, we basically consider either the spread or the location. If you are considering the spread would be the range of the data or the I keyword, that is interquartile range. Okay, these two things, like with respect to the box plot, these two things can be the, these two quantities can be the uh, like measure of what, spread. And for location you can consider the median, because in a box plot we have only the idea about the median as an as a central tendency, isn't it? So we can say it's for 1 mark. So we can say either we can have a comment on the measure of location, or we can have a comment on the measure of spread. So which one you can say? Let's consider the measure of location. So measure of location, if you are considering the measure of location, let's consider the what? Median, right? So median for birch trees, it's what? It's 48, right? But for the maple trees, it's what? 45. So we can say that on average, birch trees has what? Taller lengths or taller heights, or you can say greater heights than maple trees. Yeah, since the median, like the median of birch trees, it's what? Greater than, that is 48 centimeter. Sorry, birch trees, it's what? 48 centimeter, which is greater than the median of the what? Maple trees. That's what we can comment here, right? So what we can write here for part E is that, for part E we can write Q2 for birch trees, right? Birch trees is greater than Q2, that is how much? 45 centimeter. You can mention it. 48. Yeah, 48 centimeter for birch trees is greater than the Q2 for what? Q2 for maple trees. Fine. For maple trees, right? That was how much? 45 centimeter, right? Okay. So on average what? Birch trees grows taller, or you can say higher than what? Maple trees. Birch trees grows grow taller than what? Maple trees. That's it. Part E done. Okay. So next is what? We need to consider part F, the last part of this question. Okay. For part F, they are saying the researcher realizes that he missed out 4 pieces of data for the maple trees. For maple trees, the researcher has missed out 4 pieces of data. Okay. The heights each seedling grows in 1 year to the nearest centimeter in ascending order for these 4 maple trees are what? 27 centimeter, a centimeter, 48 centimeter, 2 centimeter. Okay. Given that there is no change to the box plot for the maple trees given on page 3. Fine. So due to these 4 missing data, the box plot of maple trees, it's not changing. This is very like conceptual question. So for part F, they are asking find the range of possible values for A. We need to find out the range of possible values for A. Now let's consider the concept. What's the concept here? Look, the first data that is missing, it is 27. and the third one is 48. Let's consider the two positions, 27 and 48. Where does 27 lies? Look, 27 lies here, right? This is 27, right, which is before the lower quartile, right? This is 27, which is before the lower quartile, and then 48, which is basically here, which is between the Q2 and the Q1, right, which is between the Q2 and Q3, yeah, the median and the upper quartile. So they said the shape of the like the box plot will be not changing. That means the shape of the box plot is not changing. That means what? The position of the 4 data values would be at 4 locations. How? Since one is here, that is before the lower quartile, and the third one is between the median and the upper quartile, so that means the next 2 must be at this location and that location. That means above Q3, and the second one would be between the Q1 and Q2, in order to keep the box plot unchanged. Fine? Because the box plot, it depends on the number of data, right? N. So if the 4 data values are at 4 locations, then their values will remain same. Okay, so let's consider the second. So that means the second one is what? A. Okay, for part F we need to show the workings. For part F, what we can say, A should be greater than Q1 and less than what? Q2. So what's the Q1? Q1 is basically 39, right? 39, and Q2 is what? 57. Okay, 57. But if you see the fourth missing value, the fourth missing value is basically twice of A, right? Twice of A. So if you consider twice of A, and if you consider the lower limit for A to be 36, then 36 times 2 would be 72, and if you consider the upper limit to be 45, sorry, 45. 39, it's for the what? It's for the birch trees. Okay, so Q1 here, the Q1 should be how much? From let's take the reading from the box plot. It is 36 and 45. Okay, it is 36 and 45. Okay, it should be 36 and what? 45. Okay, so if you see twice of A would be what? Twice of A would be 72, right? Twice of A would be 72. So twice of the upper limit would be 90. So that means twice of A would be what? Greater than 72, less than how much? 90. But 90 lies outside. The upper limit is what? 80, right? So that means twice of A should be less than how much? 80. Let's consider that. We need to write this, write this here. But what? Twice of A should be less than 80. So A should be what? Less than 40. Therefore, what we can write? Combining the two range of values of A, we can write A should be greater than 36, and it should be what? Less than what we can say? 40. Less than 40. If this is the scenario, then the addition of the 4 missing data will not change the shape of the box plot. Done. And that's all about the first question of Statistics 1 May 2024 paper. That's it.